What's going on, guys? Let's go over this true or false, okay? You don't want to mess those up on the test. A is diagonalizable if A equals P times D times P inverse for some matrix D and some invertible matrix P. Well, is this true or false? Well, this one is kind of trivial, but based on a technicality, this is false. The reason why this is false is because the symbol D does not automatically denote a diagonal matrix, okay? This D could stand for some other matrix that's not the diagonal matrix, and therefore this is why the statement is false. And honestly, that's a trivial thing, but it is what it is. Let's move on to B. If R to the n, Rn has a basis of eigenvectors of A, then A is diagonalizable. Well, go back to that one sentence in the book and it'll show you that this statement is true. Right here, read this sentence. In other words, A is diagonalizable if and only if there are enough eigenvectors to form a basis of Rn. We call such a basis an eigenvector basis of Rn. So if Rn has a basis of eigenvectors of A, then A is diagonalizable, and that is true. If you don't believe me, reread that sentence again. Part C. A is diagonalizable if and only if A has n eigenvalues counting multiplicities. Well, read up. There's this other sentence in the book that says that this is false. The statement is false. It is not necessary for an n by n matrix to have n distinct eigenvalues in order to be diagonalizable, okay? The statement I just read directly contradicts this one right here, so that's false. If A is diagonalizable, then A is invertible. So this one is actually kind of tricky because, and I was a little fooled by this, but in section 5.1, what did we say was a reason why a matrix was invertible or not? Well, whether something is invertible depends on whether zero is not an eigenvalue, okay? As long as 0 is not an eigenvalue, then the matrix is invertible. But the thing is here, go back to example 3. So you have 5, 0, and minus 2, and it says that A is diagonalizable right there. So we know that 0, based on that, 0 is an eigenvalue, and it was invertible, or it was diagonalizable. So but that matrix up there was not invertible because 0 was along the diagonal, okay? So this statement is false. If you don't see the logic, I invite you to go back to that example 3, okay? But this is a false statement too.